In this problem, we're given the diagram that's presented on the screen there, and we're given a few pieces of information. We're first told that segment GF is congruent to segment JH. So let's mark up the diagram. Then we're told that angle GFH is congruent to angle JHF. And so let's mark up those angles. Now the goal of this all is to prove that triangle GKJ, that's up in the top there, is an isosceles triangle. And that's our task here. So we're going to start out, we have these overlapping triangles going on, and we're going to start by sliding them apart. So the triangles I'm referring to are GFH and triangle JHF. Now, using the information that we've already marked onto the first, to the original diagram, we know that segment GF is congruent to segment JH, and we know that angle GFH is congruent to angle JHF. Now, one further thing that we can deduce from the picture is that these two triangles have a shared side, which is segment FH. So if I mark that on the original and then mark that on each of the separate diagrams, from that we can now see that these two triangles are congruent by side angle side, or by the side angle side postulate. Now, using the fact that they are congruent, we can use CP/CTC, or corresponding parts of congruent triangles are congruent, to assume then that the hypotenuses of those two triangles are congruent, and we can mark that onto the original diagram as well. But the hypotenuse in the original diagram is made up of two segments, and so I'm going to hold off for a second on labeling those. Instead, we have some more information we can get from these two smaller triangles. We do know that angle FGH is congruent to angle HJF, and I marked those up in the original diagram. We also know that the smaller angle, the GHF, is going to be congruent to JFH, and those we can also mark up in the larger diagram, in the original diagram, like so. Now, with that bottom triangle, FKJ, we know that since the base angles are congruent, that the sides have to be congruent also. And so now we can mark up just the segment FK has to be congruent to segment HK. Alright, we're getting there. Now, we've gone from looking at those two triangles to looking at the bottom triangle. Now we're going to look at the side triangles. And there's one more thing that I want to mark up on the original diagram. Since we know that the big angle GFH, which is a given, is congruent to angle JHF. And we know that those smaller pieces, which were JFH and GHF, which I mark with 3 bands there, are congruent. Then the whole angle minus the small angle leaves angle GFJ, which must then be congruent to angle JHG, and I'll mark those up. And we get that simply by subtraction, rather. Since the whole angles are congruent and the smaller parts of them are congruent, then when we take the smaller parts from the congruent wholes, then that has to leave a congruent larger part. Now, since we know that those two angles there in the side triangles are congruent, now we can work on those side triangles. And they look something like this, and we'll label them GFK, and the other JHK. And we'll also label on them what we can see from the original diagram now. We know that angle G in the smaller diagram is congruent to angle J. We know that angle F in these two separate diagrams is congruent to angle H. And we know that GF is congruent to JH. And that tells us that these two side triangles are congruent by angle side angle. And then using CPCTC, we can also state that segment GK is congruent to segment JK. So I mark them on the separate triangles, and then I'll also mark them on the main diagram. And now we can see that triangle GKJ must be an isosceles triangle because two of its sides are congruent. And so therefore, triangle GKJ is isosceles. And that should do it for this particular problem.